Hello, my name is Alex Velasquez, and I'll be helping facilitate today's webinar titled Cisco ACI and HashiCorp Terraform. During this session, we will explore how Cisco ACI and HashiCorp Terraform can help you increase productivity while reducing risks for your organization by managing infrastructure as code. Please feel free to type your questions during the webinar using the Q&A feature. And this webinar will be recorded, so the recording will be available after processing. It usually takes a couple of days. Now I have the pleasure to introduce our speakers, Kevin Colvin, Senior Solutions Engineer at HashiCorp, and Devarshi Shah, Senior Technical Marketing Engineer at Cisco. On our next slide, we can see today's agenda. As you can see, we'll hear about a generational transition currently underway, the business requirements driving change, and how HashiCorp Terraform and Cisco ACI can help organizations adapt via infrastructure as code. We will finish with a demo and a question and answer session. So now, here's Kevin, who will start the presentation. Thank you, Kevin.
Thanks, Alex. And Devarshi, good to be back with you and working with you on this project and webinar. It's been fun collaborating with you.
Same here, Kevin. It's been a lot of fun collaborating with you on this project.
So over here at HashiCorp, we talk about this sort of generational transition that's underway, where customers historically had these like dedicated servers in private data centers, and then moved into more of a private cloud world where they had a pool of compute and kind of capacity available on demand. And now we see customers adopting more of a multi-cloud strategy where they picked one or more of the public cloud providers. And this has largely been driven by kind of what Jeffrey Moore would call this systems of record or systems of engagement phenomenon, where by and large, the core business databases and internal applications, or those systems of record, will remain in on-premises data centers, and then net new applications like mobile applications and things of the like there would be more designed for a public cloud because of the scale and efficiency of those infrastructures. And so, kind of the reality that customers find themselves in is this multi-cloud world where I'm still going to have to continue to maintain my on-premises data center and those systems of record. And at the same time, I have to square that away with how I'm operationalizing public cloud infrastructures, today. And this has been largely driven by an evolution in the application workload delivery too. We went from physical to virtual machines, and now we see cloud native application methodologies where we're talking about containers and serverless technologies, as well as pushing compute down to the edge. And in the face of kind of all of these headwinds, we're challenged with how do we help customers enable them to deliver applications to the cloud and across the clouds with consistency. We think about that in terms of workflows and not technologies when it comes to our products, and ultimately those workflows are how do we help customers provision, secure, connect, and run these applications with consistency. But I'm really interested to hear your take on it and how Cisco's thinking about this from the network standpoint. So why don't you give us kind of a little bit of background on what you guys are seeing over there?
Sure, Kevin. So from Cisco point of view as well, we are seeing similar trends. And what I'm going to do is I'm going to talk about the business requirements that are there for the network infrastructure and what it means for an IT team that's driving the network infrastructure. So the way you have applications delivered has completely changed. You have applications which are more personalized. You have applications which are using AI and ML components. And most of all, you have applications which are being built and consumed on different platforms, right? So as a result of this, the IT operations has become complex. You have to have data center operations and data center networking, which has to be up all the time, and there is no room for error. The second thing that we see is essentially businesses want to have competitive advantage, and competitive advantage not just by having saving costs and having more agility, but by actually delivering business innovations. And public clouds or cloud-based architectures and data centers are a very good way of doing that, because it allows you to have the flexibility of enabling your development teams faster, delivering your products faster to the market. And as a result of that, you have multi-cloud challenges that infrastructure teams have to handle, right? So this could be in terms of the security of the multi-cloud environment, what are the compliance parameters. You may have a vendor lock-in with, let's say, a particular public cloud provider or a particular vendor. And then essentially you have a gap of skills where you have one person or one set of team proficient on, let's say, AWS, another one proficient on Azure, third one proficient with Cisco technologies, right? That's another hurdle that arises. And lastly is applications that are delivered as virtual workloads, as containers, and physical workloads as well, right? So as a result of this, your surface area for attacks is much wider. So security becomes a key component as well. So in order to address this, we came up with ACI, application-centric infrastructure. For those of you who are familiar with ACI, this is just a quick recap, but those of who you are not familiar with ACI, I'll just give you a brief introduction to what ACI is. In order to do that, let me give some insight into what traditional networking was. So traditional networking, you'd go into a particular switch, you'd use CLI to configure it, and you'd basically do that operation over and over again on other switches to bring up the network. This was okay, and this could be achieved if your scale of your network was smaller. But now the requirements of the applications and the scale of applications is much larger. So this doesn't scale. The second problem with second aspect of traditional networking was the language that is used by network operators. Let's say, like, for example, allowing an IP address or blocking an IP address doesn't have so much of a relevance with the application world. So there was a need for an SDN-based architecture which would mitigate a lot of these problems, which is why we came up with ACI. Now, ACI is an SDN-based architecture where you have a controller, which is APIC, Application Policy Infrastructure Controller, that you can see in this diagram, which provides an abstraction for its users where they can define the network configuration in a very application-like manner. And APIC will take care of translating that into the underlying infrastructure, which when we started was the Nexus 9000 series of switches. So what this allows you to do is it allows you to have automation to bring up and manage the life cycle of these switches, have the networking running. Second thing that we did was the ACI policy model, or the abstraction that we provided, was a whitelist policy model. So it has the capabilities of being whitelisted, where you can say workload A is not allowed to talk to workload B unless I specify a networking policy. So it becomes a lot more secure. And since it's a single orchestrator, a single point of control, you have a lot of visibility into what's going on in your network, and troubleshooting becomes much easier. Now, the customer requirements grew as well. So customers wanted to have this ACI architecture, not just in one data center location, but in other data center locations. And the use cases that enabled these were essentially disaster recovery, application stretch, right? So you want consistent policies across your data centers. You want those connectivities, which is why we came up with architectures like remote leaf and virtual pod, which could run in remote locations. And then there was a need to essentially have this sort of an infrastructure that would basically provide connectivity between your cloud workloads and help manage your cloud workloads across multiple clouds, right? Not just AWS, not just Azure, GCP as well, along with these different data center sites in a consistent manner. So if you train your teams on ACI, you can have it being used anywhere. And an important component of this architecture is an Uber orchestrator that we call as multi-site orchestrator, where you can define consistent policies and say, I want this policy to be applied to site A, B, or C, and that site can be on-prem as well as your cloud instances.
Great, thanks for the background, Devarshi. I guess to kind of return in kind for the audience, we have a mixed bag of folks that might be familiar with ACI and not Terraform, or vice versa. So I'm going to do a quick level set on what Terraform is from HashiCorp. We see Terraform as this unified provisioning plane for multi-cloud, and we want to provide a couple of key benefits. First is enable an infrastructure as code operation model. We'll drill into this a little bit more throughout the course of the presentation, but infrastructure as code's goal is to allow us to efficiently provision and manage the entire life cycle of this infrastructure across any scale and across any number of cloud providers. In doing so, we want to be able to offer our customers multi-cloud compliance and management. So it's one thing to automate and provision infrastructure. It's another thing to make sure that we're automating and provisioning the right infrastructure in the right place in accordance with the corporate standards and governance that we might have in place. And we want to do so in a proactive manner. So this isn't a reactive, like scanning the environment and figuring out if somebody provisions something badly. In this day and age, those sort of reactive security controls are sometimes too late. So at provisioning time, we want to enforce that. And then finally, enable our customers to have this notion of a self-service infrastructure where teams can collaborate around the infrastructure as code and do so by publishing these confirmed and approved modules that can be used for consumption without having to kind of recreate the wheel every time. And the actual execution model of Terraform and how we take that infrastructure as code artifacts and push them into production is split into two phases that I think aligns well with kind of how customers think about provisioning infrastructure. The first phase of it is a plan phase where we would look at, what is the infrastructure as code definition? And is it already provisioned? Do I need to provision it? What needs to change in sort of the real world to accomplish what the code has told us that we want our infrastructure to look like? And this also gives us an opportunity to collaborate and review around what those changes might be and make sure that they're the right changes and that everybody's kind of on board with that plan. And then we would move into an apply phase where this is where we're reconciling what the definition of the infrastructure should look like compared to what it looks like in the real world in these target infrastructures. We break this down into the core engine, which I've described here in the plan and apply phase, and the outputs being that state of what has been provisioned, and then being able to kind of reconcile that with the target infrastructure and what's actually provisioned. But then we also have this notion of a Terraform provider that decouples the execution and the workflow from the underlying technologies. In this multi-cloud world, as we've described, customers certainly want to provision things in Kubernetes and Amazon and Google Compute and Azure, but they also want to pull in things like Cisco ACI or maybe F5 load balancers or VMware VMs that also need to participate in this infrastructure to deliver the applications. And so Terraform today has over 200 providers. Our open source offerings have over 100,000 weekly downloads. And we also have enterprise versions that really accelerate the adoption of Terraform as a unified control plane within large organizations and facilitate that collaboration around infrastructure. Because we also recognize that there's different disciplines in infrastructure. You have network teams, server teams, application teams that are ultimately the consumer of that. And a lot of times that kind of layer 8 challenge of the collaboration across those teams is really where the difficulties lie. And those are what we try to solve with our enterprise offerings.
So Kevin, I just want to double click on the concept of modules because that is important. We have, as you say, two worlds colliding here. So your infrastructure network operations teams and your app dev teams, right? So the module provides a very consistent way for you to essentially create a workflow without any hiccups or frictions.
Yeah, absolutely. You know, we look at that, the module as kind of in the terms of producers of that module, and then ultimately the consumers of that module, where I want to abstract out the gory details of how we kind of think about the infrastructure and just let them say, I need infrastructure and I want to run my applications on it. I also want to double click a little bit on infrastructure as code. And this may be a new concept for some on the webinar here. But the reason that we like infrastructure as code is, number one, that it's been proven sort of in the multi-cloud and public cloud architectures. We've been able to see customers be very successful managing very large scale infrastructures using this paradigm. And the real benefit of it is that we're codifying the definition of that infrastructure and then leveraging those code artifacts through tools like version control. And we can answer some of the fundamental questions that a lot of IT infrastructure operations teams have. Who changed something in the infrastructure? When did they change it? Why did they change it? And then really getting a track record of that kind of tribal knowledge that exists in a lot of these environments, with the ultimate goal of reducing human error. You know, the complexity of these multi-cloud architectures has gone up tremendously, and relying on a human to consistently point and click through GUIs or you know, run through standard operating procedure scripts and get those 100% precise every single time is kind of unrealistic. So we codify it into version control. That codification becomes sort of an executable documentation as we think about it. And as this relates to kind of the networking, what we're going to show in the demo later on is this ability to kind of take on more of a GitOps workflow, where as I am proposing changes to my production infrastructure, I can fork out the current state of what that production infrastructure looks like, make my changes there, collaborate around it, go through any approval workflows that are required, and make sure that we're absolutely confident that when we provision that infrastructure, when it's time to go and the change window is here, our confidence that it's going to be successful is very high, because we've validated through this notion of policy as code that this is actually in line with those industry or with the best practices, industry best practices, and then sort of corporate standards. So also layering on a level of governance into the discussion. Which brings us to the Terraform provider for ACI. Devarsha, you want to give us a little bit of background on kind of what's been going on here with the joint development effort?
Sure. So before I go into that, I want to emphasize why infrastructure as code is important for network as well, right? So we've spoken to a lot of customers, and I'll point out two key statistics that we found. First is 97% of network operators say that human error or a human factor is responsible for a network outage. The second is 74% of network changes have a business impact. So these are pretty telling statistics, which is why it's important to have infrastructure as code in networking as well. And I've been glad to say that Cisco and HashiCorp have been collaborating since last year to build out Terraform Provider, which includes 65 plus APIC resources and 15 plus cloud APIC resources. This provider was upstreamed in Q3 of calendar year 2019, so it's been generally available for a while. And it enables Cisco ACI users to have infrastructure as code capabilities and merge into the wider ecosystem of Terraform. Now, in terms of capabilities that infrastructure as code provides, I want to basically break it down into capabilities and outcomes for your business. First is infrastructure as code allows you to treat your network configuration and manage the entire lifecycle of it. So what happens is you can have the same lifecycle management across multiple teams. You have automation in place, which allows you to scale up your network faster. What this means is you can have cost savings and you can put in rules in your infrastructure as code to be compliant. You can see what is the change that's happened. You can, if an auditor comes up, you can provide that report, right? The second is, since it integrates really well with CI/CD pipelines and you have the actions of plan, you get to know what is the configuration that you're pushing down on your network, which makes the changes a lot more safer and predictable, which means you have a higher uptime of your networking infrastructure. And the third is both ACI and Terraform have multi-cloud capabilities, which means you don't have to be limited by a particular set of platforms. You can innovate and have competitive advantage. So let's drill down into what infrastructure as code with ACI is, and this gets into more technical details. In order to understand this, I'll go through some key ACI terminologies that you see on the screen. First is tenant. Tenant is essentially a part of the abstraction that we've created for ACI, which provides an isolated container for all your networking policies, all your AAA login, security policies, all of those things for users. So let's say you are a service provider who's running an ACI fabric. You can have a tenant for client Coke, and you can have a tenant for client Pepsi, which essentially share the same physical infrastructure. Now, any device that attaches to the network, it can be virtual, it can be physical, it can be a container workload, it can even be a firewall or a load balancer, is considered as an endpoint. And ACI allows you to classify endpoints which have a similar connection requirement into what we call as endpoint groups. So those of you who are familiar with the AWS side of things, think of it as a security group. And ACI allows you to define the communication between these sets of endpoints through what we call as contracts and filters. So again, AWS side, inbound and outbound policies, right? So you have these constructs, and all these constructs have interdependencies between them. And when you configure your ACI fabric, these interdependencies form a tree, which we've shown on the right. And you can access any object in this interdependency by its distinguished name. So think about it as a directory structure. So for, let's say I want to access an application profile or a VLAN, I'll go into policy universe, I'll go into VLAN. You can form a URL like that. And this is essentially, this entire tree is available to you as an API. And that forms the basis of integrating with Terraform and a lot of other technologies.
Yeah, so Devarshi, when you talk about ACI and the object model, one of the things that I think is really unique about this integration between Terraform and ACI is this notion of a resource graph that we construct on the Terraform side. And what we're able to do is parse through the interpolations that exist in the infrastructure as code artifacts, and we can determine those dependencies. You have these kind of containers that have, I have to create the top level container before I can create the child objects, and traditional kind of scripting approaches or other technologies that are out there, that puts a lot of burden on the practitioner to kind of say, I have to think about and reason about, like, what is the sequence in which I want to lay these resources down, and I have to be precise about it, and I have to think about it throughout the whole life cycle. The workflow or the order of operations may change between when I'm provisioning something to spin up a new development environment, as well as when I'm deprovisioning that because the work in the development environment is done. The other thing that this graph brings to us is the ability to, as we understand those dependencies, we can also look at where we've resolved them and we've provisioned all of the things that are required first, and take the opportunity where there's independent resources and launch multiple parallel threads to really streamline and make the infrastructure provisioning as efficient as possible.
So how this ties into ACI is shown on the right? So you have dependencies that are created between ACI objects. So what the Terraform provider for ACI does is essentially it figures out these dependencies by itself. And you as a user don't need to specify that this is the order in which it needs to be present. You don't need to know how the objects are interrelated. You can just define them, and Terraform will take care of, the Terraform ACI resource will take care of figuring out the dependencies. Another thing that Kevin mentioned was parallel execution threads, right? So for example, you have a configuration for tenant that you want to provision, and then there's some configuration for the interface that you want to provision. Both of these are not related to each other, so you can run a parallel execution thread or two parallel execution threads for provisioning them.
All right, so let's get into the demo portion here. I'm going to leave my video off here to allow for the full real estate of the viewers to see. And as they say, I also have a face for radio. So the two demos that we're going to kind of run here are, I'm going to go through a first one where we talk about how do we take kind of the traditional network architecture and network engineering and operations teams and really embrace this infrastructure as code paradigm by enabling them to collaborate around version control repositories and then start to think about how they provision infrastructure in more of a continuous integration, continuous delivery workflow. So we've talked about Terraform modules briefly, but when we think about this in the context of ACI, there's a couple of different things that bubble up for me. The first here is we're going to demonstrate this fabric policies module. And this is where the network architecture team is going to really think about like what are the core policies that should be in place in every ACI fabric that I deploy, whether it's in my primary data center or disaster recovery, things like CDP or LACP, storm control that are kind of like, I want to fire and forget them, but I also want to make sure that they stay consistent over time. And if somebody's in the UI maybe tweaking things, I want to make sure that it's consistently provisioned. The second is kind of the adds, moves, and changes effect of this, where now we have, based on business requirements or new applications coming up, we need to spin up additional infrastructure to respond to some sort of demand from a downstream consumer. And so the way that we think about this with infrastructure as code is, I want to be able to reference this module into a version control repository that represents sort of the master or the production, data center, whichever that may be. And then I want to reference that policy in there and not have to kind of rewrite that code every single time, get a degree of reusability. And then for those adds, moves, and changes, when I'm proposing changes to my infrastructure, I want to be able to kind of create a branch off of the master, start to validate and collaborate around those changes. In this case, we're going to show, a new EPG coming up that represents kind of a VLAN type of construct in the networking world, and then push that through a CI/CD flow using Terraform Cloud for the demo purposes. I do want to call out that Terraform Enterprise might be something to consider too if you're needing to touch that infrastructure behind, say, a corporate firewall, or maybe you don't want to kind of whitelist out access to your APIC controllers from the internet. We find that's a concern that a lot of enterprise customers have. But then really move through that kind of Terraform workflow that we outlined, where we're planning, outputting the state of the current resources, and then enforcing some level of governance around what should we be provisioning into the fabric. So, and then finally, we're going to push it into more of an on-prem kind of scenario. I already want to call out here, for purposes of demo, I'm using the Cisco DevNet Sandbox as my APIC controller. This is a great resource if you, after the webinar, if you want to get started kicking the tires with some of this integration, great learning place for you if you don't have access to an APIC controller that you can, sort of do some testing on. So with that, I'm going to end the slides here and kind of give a brief overview of what we're going to be showing here. First of all is our APIC console. And then also we're going to look at these modules that we described. So the fabric policies and the EPG VLAN policies. As a consumer of these, I can look at through the definition, and I can kind of say, what is this module providing for me? And it's those high level policies that we talked about. And the modules themselves are version controlled through other repositories that are collaborated upon. So if we look at, like, say, this ACI fabric policy, I might have my high-level CDP resource that defines, that says on every port in my fabric, I do want CDP enabled, and I can define that as a resource in Terraform configuration. And then likewise, maybe something like an LACP policy for my physical servers, or my ESX hypervisors need to have some sort of LACP or NIC teaming applied to them. So I want to have those baseline policies and things in the ACI world consistently deployed. The flip side of that is on the kind of the adds, moves, and changes, the CPG VLAN, looking at kind of that high-level construct that you described about how we make this consistent and repeatable across provision cycles. And then finally, we pull this all together in terms of a very simple definition of what we want our fabric to look like. So I initialize an ACI provider for Terraform. I reference the module that defines those baseline fabric policies that we want consistently deployed everywhere. And then I have multiple invocations of kind of that VLAN construct using the EPG module. So when we kind of put this in practice, right, we're taking more of this GitOps workflow where, somebody might raise an issue because this new provisioning needs to happen. You can see I created this issue prior. We'll go ahead and work it now on the demo. So the first thing that I'm going to do is create a merge request. And that merge request, again, is this kind of notion that, hey, we're proposing some changes to the production environment. So let's create a new branch for that code and say, we're going to look at what actually means. And I can simply come in here and make some high-level modifications by editing this through, in this case, we're using GitLab and their kind of integrated IDE environment. But really any version control provider that your organization may be using is, just fine and has similar concepts to it. So what I'm going to do here is just make a few changes, and we're going to provision this kind of demo tenant in here. And I'm going to go ahead and commit those changes, making the proposal, the proposal that I want to go into production. And then pop back to my version or my merge request here. And what we're going to see is that immediately a pipeline is kicked off for us. And that pipeline is going to actually go through and execute the, in Terraform Cloud, that plan phase that we're talking about. It's going to go out and reconcile what the differences are between what I've now defined in my code and what the the sort of reconciling the real world with what our infrastructure as code definition is. Now, we also here are doing this sort of governance check around, is it actually, what we should be provisioning? And in this case, I violated a policy that my organization has set up that says my tenant names need to have 5 uppercase characters and then be suffixed with -tenant. We're enforcing this level at a soft mandatory, which means that if I really wanted to and I had the appropriate permissions, I could have somebody override that policy. In this case, we're giving feedback to the user that says, you know what, I can now go in and edit my proposal to be in line with the corporate standard. So let's go ahead and do that. So I'm going to come back into my branch that I'm proposing here. And I'm going to edit that file one more time. And I'm simply going to change the demo name here to be Acme C. And if I would have been paying attention, I could have seen that, yeah, it looks like that is some sort of a standard. So I'm going to go ahead and add an Acme C tenant and commit those changes again. And the process is going to kind of repeat itself here again. We're going to kick off another pipeline for that, running through that plan phase and validating that that is in fact, now in compliance with, those standards that the organization has put forth. So we'll let that run here, and I'm going to go back to the merge request here to just assume that everything's going to work well there. We'll verify that again and have an opportunity to kind of show some more of the workflow here. Inside of my merge request now, I can say, you know what, I think I'm actually done, and I just got the pipeline passed, which means now it does look good. Everything's okay. So I'm going to go ahead and mark this as complete from my end. But what you'll notice is that now I can only merge this once it's approved. So even though I'm proposing these changes, I don't necessarily have access or the rights to directly merge that into production. Instead, I want somebody else to review this change, having all of the pipeline and policy checks that have been passed or failed, and then ultimately give them the ability to sort of review it. So in this case, Devarshi, I need some approval on this merge request here. Would you mind in the background there kind of going in and approving that?
Sure, your changes look good. I've approved them.
Okay, so with that in place, I'm going to go ahead and refresh here, and you see now I can in fact merge it. So we'll go ahead and merge that. During that merge request, again, another pipeline is going to kick off that's going to show now we're moving this from the couple updates that I made, and now we're merging this into our master branch, which represents the production environment that we're dealing with here. So we'll let that run through. And again, kind of rinse and repeat here. We're going to go back through the plan phase one more time, just to do one last dry run through our policy check, and then finally get into the apply phase where we're actually making this a reality. This should take just a few seconds here, and we're going to see that, in fact, we said we're going to add 6 resources. The policy checks passed. We're reconciling the infrastructure state and then creating those new resources. And we've successfully moved our proposed change into production with compliance and governance around our provisioning policies. And Devarshi, I'm going to hand it over to you to run us through the second demo.
Sounds good. Is everyone able to see my screen?
Yes, we can.
Perfect. So what I'm going to do in the second demo is slightly different from what Kevin did. I'm going to be focusing on 3 things. The first thing is Kevin showed you how to use Terraform with ACI in a CI/CD workflow, right? I know a lot of you on the call are essentially trying to figure out what is automation for the network, how to get started. And I don't want you to go away with a feeling that it is overwhelming to start with it, which is why I'll focus on a Terraform CLI-based workflow, so it becomes a lot easier for you to see how to get started. The second thing that I'm going to focus on is essentially the workflows between teams, right? I know in ideal world, we want one team that has expertise in terms of your network, your application, your security policies, but that is not the case. You have siloed organizations where you have your network teams, which are proficient with managing their ACI or Nexus networks. You have your app dev teams, which are good at deploying the application, right? So how do we create consistent workflows between those teams? And I'll walk you through an example for that. And lastly, we are going to run this demo on Cloud APIC, which is a very important component of the ACI Anywhere architecture. Cloud APIC is essentially a virtual form factor of APIC running on AWS. It takes in the ACI policy, which means you can configure your AWS environment and the networking for it in the same way as you do for your regular on-prem ACI. And it will make sure that you have connectivity to your different ACI sites, as well as between different regions that you might have within your AWS environment. So those are the 3 things that I'm going to focus on. So first off, I'll play the role of a network operations team, right? So the network operation team knows that, hey, I need to provision a network on Cloud APIC. I need to set up the networking for it. So they will essentially create the bare bones or day 0 configuration that's required in terms of, let's say, create a tenant, create a VRF, create a cloud context profile, all those things, right? Now they've created the network in a steady state. Now, how do I make the configuration that I have consumable for other teams? So what they do is they create a module where they say, you as an application team will put in some input parameters, which you are familiar with, like app tier, what are the allowed ports, what is the app name, all of those things, right? And I have created a module underneath which includes ACI resources, which will provision the cloud APIC, right? So you as an application developer just need to invoke that module with the parameters that you are familiar with. The network team has already put in the logic of creating the ACI construct, so you don't need to be completely aware about it. And then the network team will have an output, right? So it will say, hey, this is the subnet that you should use to bring up your application instances, right? So in this demo, we are going to spin up a 2-tier application. And the workflow that I'm going to start with is essentially the network team has provisioned the day 0 configuration of Cloud APIC. And they've said, and the application development team wants to provision a 2-tier application. So what you can do is essentially as a network team or an application team operator. So right now I'm working as an application team operator. You can do a Terraform plan. And this will essentially tell me that, hey, I'm provisioning an application on an EC2 instance, which is T2 micro. This is the subnet that I'm using, right? And this will also take in the parameters that I've put in for my application connectivity requirement and provision the underlying ACI policy. I don't need to be worried about that. So the module network definition is made available to me by the network team. I'm not filling out any of the details for this. I'm just saying Terraform plan, my EC2 instance needs to come up. Right, this is what my EC2 instance needs to come up. And then I can just do a Terraform apply. So this will take some time to spin up. So in the meanwhile, what I'm going to show you is first, the module that the network or the application team is using. Second is what that module looks like. And third is how is that module getting the state of the network from what the network team is provisioned. So first is, let's go to the module that the network team has made available. So the module that network team has made available is this particular module, where you as an application user will just say, this is the name of my application. These are the application tiers that I want. These are basically the conditions which tie an EC2 instance into a particular tier. These are the set of policies and whether I want internet access or not. So these are the variables that you can input. Let's go take a look at this module, right? So this particular module is available to you here. And if I go into the details of this module, essentially it's the ACI resources that I'm provisioning underneath. So the app dev team doesn't need to know about this. They don't need to know about resources for ACI. They don't need to know about the underlying networking context. This is available to you. So you have a resource for application profile, you pass in the tenant name, all those things that are available to you. And these tenant names are essentially fetched by this particular module based on the output that the network team created for everyone to consume. And the output of what the network team produced or looks something like this. So I have Terraform Cloud, which is my backend for saving my state and my variables. And I'll go into my organization or the workspace for the network operations team. And if you see, my network operations team has already provisioned the underlying networking. They have made these variables available for anyone to consume, right? So all I care about is what is the AWS region, what is the tenant that I need to use, and what is the VPC that I need to provision this network in. So this becomes a very repeatable model for you to build on top of in terms of collaboration between different teams. So while this is going on, let's double click on what is the state of the configuration that I'm trying to apply through as the application team, right? So I can go into the applying state. As you can see, my application instance is coming up. I am essentially pushing in the application code here. And this will take just about a minute or two to get up and running. While this is going on, I want to show you the day zero configuration that the network team pushed out, right? So the day zero configuration that the network team pushed out was essentially this, where they are creating an ACI tenant, where they're defining a resource ACI tenant, the resource type, and then giving it a name, passing in some variables or attributes to it. You're creating a VRF, you're creating your cloud AWS provider, you're creating your bridge domain, context profile, CIDR, and subnet. These are all terminologies which ACI operators are very familiar with. And once this was configured and done, and when they ran Terraform, the state of this run was essentially stored in their workspace, NetOps. And this was the state of the run that they had. So you created your ACI Terraform tenant, you created your AWS profile, all of those things. And just to tie everything back together on ACI side, I'm going to log into Cloud Epic, and I'm going to show you that the tenant that we created was essentially Cisco IT. You have policies in it for a two-tier application, which means you have two endpoint groups, DB and web. You have a set of contracts between them, which essentially say that I want to allow these ports or these policies. And because you've applied this configuration to ACI, ACI will take care of creating the underlying cloud resources, which include the VPC, which include the subnet as well that's associated with it, and the security groups that are needed to essentially translate that. So you can have a consistent workflow across different teams in different environments as well. And now let's go back and check on the status of the run that we have. So it's still going on. So I think it's almost about to be done right now. And once this is done, we'll have a two-tier application with the application code running on EC2 instances, DB, and web. And you'll have the application available on this particular public IP address. So I know this might take probably a minute or two, and I think we are slightly running out of time. So what I'll do is I'll jump into the resources that we have available for you to get started. First is the Terraform repo for ACI Provider. And this is a good way for you to put in new feature requests in terms of resources that you want and raise issues. The second is the Cisco developer community. So Cisco DevNet is a very good resource or a tool for people who are starting on programmability or are looking for examples on programmability with not just ACI, but other Cisco technologies. Third is the provider documentation. We've extensively documented the capabilities of the provider. And for those of you who are not familiar with Terraform, we have the resource for getting started on Terraform as well. And lastly, what's next for the ACI technologies and HashiCorp? First, I'm really excited to say that we are working on an integration between ACI and Console, HashiCorp Console, which is their service discovery, service registry, and service networking product. the use case that we are working on there is essentially providing the service level visibility into the ACI fabric or into your APIC, where you know that a particular service ties to these ACI or networking constructs, and essentially overlaying the health as well. And the second is the multi-site orchestrator provider for Terraform as well. So this should be available shortly, so stay tuned. Back to you, Alex.
Great. Thank you so much, Kevin and Devarshi. At this time, let's open it up for questions from our audience. We've had some so far, so let's start with this one here. Can anything in ACI be provisioned from Terraform? Kevin, can you take that question?
Devarshi, why don't you take that one?
Sure.
Okay.
So we've made about 65 resources available, and that covers a lot of the configuration workflows that our operators use. In ACI, you can have essentially hundreds or thousands of different configuration elements that you can touch. So what we've done is we've provided a resource which is called ACI REST, which is essentially a catch-all. But I would say if you want to truly go with the infrastructure as code way of thinking, and if you don't have a particular resource available, reach out to us and we'll make that available. In the meanwhile, use ACI REST, but that is not the ideal way of doing things.
Great. Thank you so much. Next question. How do I manage existing ACI configuration through Terraform?
This is a very interesting question, and essentially relates to how do you bring the existing ACI configuration or a brownfield deployment into the Terraform lifecycle management, right? So Terraform has the functionality of importing an ACI resource. So you say Terraform import and give in the DN of the object that you want to manage and have some configuration in your Terraform config file. So there are in the Terraform documentation, you have at the bottom example for how to use import.
Great, thank you so much. One more, how does Terraform compare to other infrastructure as code tools like Ansible or CloudFormation?
Yeah, I can take that one, Alex. This question comes up quite often, actually, and you know, we see the kind of problem being split into two domains. One is configuration management, where I have stuff that exists and I want to manage the configuration of that stuff over time. The second is more, and where Terraform fits in, is more kind of like infrastructure provisioning, right? So I don't necessarily have that infrastructure yet, so I don't have anything to manage. So I want to, you know, do the bootstrapping of it and manage the life cycle of the infrastructure itself in that. And I think the kind of the differentiator for us is like state, right? If you have a Ansible playbook that says lay down 2 instances and you rerun that playbook 3 times, you can very easily end up with 6 instances when you really wanted 2. And so I think the other one, I think there may have been a CloudFormation piece of it in there as well, right, Alex? You know, CloudFormation is an infrastructure as code tool that's used for, you know, AWS. And if you're all in AWS, that's probably a pretty okay approach. What we see in the real world is it's a little bit more heterogeneous than that. In terms of, I need some AWS resources, I need some ACI resources, I need some VM resources, and we want to focus on kind of infrastructure as code across the whole estate.
Great. Okay. Next question, in your experience, should the version control windows be, for the network team, be open to everyone being able to view them within the company?
Yeah, so I guess my answer on that would be kind of a definite maybe. You know, the version control tools provide a level of role-based access control themselves. As you saw in the demo, like, you know, I could, you know, propose a change to it, but I couldn't actually merge that change until Devarshi approved it. And so, you know, from a, you know, like a read-only standpoint, yeah, I think the transparency is good because it enables collaboration across teams, where a lot of the kind of tools outside of Terraform or infrastructure as code as a kind of an operational model, sort of put the management in, one autonomous unit or one autonomous group, and we're not real good at kind of sharing those tools across the entire, infrastructure. And so by enabling version control to be kind of available and allow folks to kind of peek behind the covers as to what's going on, I think is a good thing that enables that collaboration.
Right. I think we have time for maybe one or two more.
So Alex, I see a very interesting question here. So
yeah,
does
sure.
Terraform Cloud allow for dedicated network connectivity to on-prem vSphere and ACI like Azure does to reach our environment? So I just want to clear a few things out. First is, in order to have network connectivity, you will need ACI. Terraform does not create network connectivity. Terraform is used to manage the life cycle of the configuration that goes in there on ACI and some other resources that are there in your on-prem data center. You would still need ACI as a technology to manage or enable the underlying network connectivity.
Yeah, and one other point on that, Devarshi, because there may also be some confusion on the Terraform side. We used, for convenience purposes, we used our Terraform Cloud offering, which is a SaaS-based offer that lives in the cloud. It's multi-tenant. We also have at HashiCorp Terraform Enterprise, which is designed for broad scale adoption, both for public resources as well as on-prem, where you may not want to kind of allow your APIC controllers in your primary or disaster recovery data centers to be exposed to the public internet.
Great. Well, that does it for our session. Thank you, Kevin and Devarshi. Thank you to the audience. I hope everyone had enjoyed the webinar and have a better understanding of how Cisco ACI and HashiCorp Terraform can help you increase productivity while reducing the risks for your organization by managing infrastructure as code. Finally, as we mentioned at the beginning, the webinar was recorded and we will make the recording available after processing. I will send an email to everyone who registered with a link to it. Have a great day, everybody, and goodbye.
Thank you.
Thanks.
Thank you.